Okay, this is page 10. If they give you a question like this, they will give you these formulas. But remember, this is for continuous interest, and this one is for compound interest. Now, because they said it's compounded quarterly, we're not going to use this formula. So I need to figure out what all these things, how long does it take $800 to grow to $3,200 if invested at 5%? So I have a P of T, which is the amount after a certain amount of time, and I have P sub O, which is the original amount. I have R, and I have N, and I have T. Well, they're asking me how long does it take, so this is what I'm trying to solve for. But they're giving me all of this, but we have to figure out where. So this is after a certain amount of time, so that would be the accumulated amount. And then the P sub O is 800. My R, remember, we write it as a decimal. And the N is how many times it's compounded. Quarterly is 4. So I take this formula and put in 3,200 for my piece of T equals 800. And then 1 plus 0.05 over 4 to the NT would be 4 times T. So I'm trying to solve for T. So I put this in my calculator. I get 1.0125 to the 4T. And now I can get rid of this 800 because it's, if I divide by 800, I get 4 equals 1.0125 to the 4T. Now remember, to get rid of an exponent, I use a log of the base that I want to get rid of. So I'm going to log both sides with 1.0125 of 4. And then when I do this side, remember what happens is the 4T comes to the front and this goes to 1. So now I just have 4T over here. On this side, I use change of base. Remember, the base of the log goes on the bottom. And I put this in my calculator and divide by 4. And I end up with about, it's 27.9, so you could say 28 years. So you have to use the log to get rid of this exponent, okay? Okay, this one is expand the formula. So remember, we're going to separate the fraction first, and that means divide. So I'm going to change this a to a to the 1/4 because we're going to have to get rid of these exponents. And we don't want radicals, so we change them to exponents. Minus log base 3 of a cubed c to the 1/2. Same thing, I'm going to change this to an exponent. So now I'm just going to concentrate on this one. How do I separate multiply? Well, I separate multiply by adding. So I get a to the 1/4 plus log base 3 of b cubed plus log base 3 of c squared. And I'm going to finish this one out, and then we'll do the other side of the subtraction. So the only thing I have left to do is bring the exponents to the front. Log base 3 of a plus 3 log base 3 of b plus 2 log base 3 of c. Now this one's minus, but remember it's minus the whole thing. So I get log base 3 of a cubed plus log base 3 of c to the 1/2, because this is still multiply. Okay, then I'm going to bring the 3 to the front, so I get minus 3 log 3 of a, but it's minus this one also. Oops, I forgot the 1/2 log base 3 of c. And so look at it like this. See, all the ones that were on the top are positive, and both of the ones on the bottom are negative. So that's your final expansion, okay? This one is just dealing with matrices, multiplying. Some of them may come out to be wrong dimensions, but we're going to look at it and see if we can do it. So A is a 2 by 2 and B is a 2 by 4 or a 2 by 3. So we can multiply this because these match. So I'm going to take these two matrices and write them down so I can multiply them. Times 2, negative 3, 1, 4, negative 1, 3. So I take negative 7, 6 and put it on its side and multiply it through. And I get negative 14 plus 24, which gives me 10. And then 21 minus 6, I get 15. See, this was the first row, the second column, so that's why I put it there. And then I get negative 7 plus 18, I get positive 11. I used the first row for all of these, so that's why they came all in the first row. I'm done with that row. Then I go to negative 4, 3, do the same thing. Negative 4 times 2 plus 3 times 4, that gives me 4. Negative 4 times negative 3 plus 3 times negative 1, and that gives me 9. And then negative 4 times 1 plus 3 times 3, and that gives me 5, and that is the product of A times B. Okay, now let's see if this one works. B is 2 by 3, and C is 3 by 3. So this one works also. So I have B is 2, negative 3, 1, and 4, negative 1, 3. And C is negative 1, 3, 2, negative 1, 2, 0. And I just take each row and tip it to negative 3, 1 and distribute it through. I'm not going to walk through every single piece of this because you can look back at the other problems that we did, but we did 2 times negative 1 plus negative 3 times negative 1 and 1 times negative 2. And for that, I got negative 1. And then the next row, I got 0. And the next row, I get another 0. So I'm done with that one. I move to 4, negative 1, and 3. So I get negative 4 and 1 and negative 6. That gives me negative 9. And then I get 12, negative 2 and 0, and I get 10. And then 8 and 0 and 12. This one is negative. Almost didn't see that up here. And that gives me a negative 4. Okay, now C times A. C is a 3 by 3, and A is a 2 by 2. So this one is not possible because they're the wrong dimensions. And you can just say not possible. Okay, now remember this one means the inverse. So I take the A, and first I do the discriminant. Negative 7 times 3 minus 6 times negative 4. Remember the minus the two diagonals. So I get negative 21 plus 24. So I start with 1/3. And then I take the negative 7 and 3 and switch their places. And the 6 and negative 4 change signs. And you could leave it like that, or you could write it as 1 and negative 2 and 4/3 and negative 7/3. They're both the same thing. Either one is fine. And that's it for this review. So now you just have to look at the other review and do the practice test. Come to class with